Hey everybody, Mr. Troy here. I got a quick video for you on how you can know how many solutions a quadratic equation is going to have without even having to do anything. It's time for math with Mr. Troy. All right. So we already know the solutions to a quadratic equation, right? If you can set it equal to 0, you know this. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. I mean, I don't have to tell you that, right? So take this time, write that down. You need to memorize this. You're going to use it for the rest of your mathematical life. Now, there is something interesting about this particular formula, and it lies right here. If you know what number goes under the square root, you know what comes out of the square root. Of course you do. But not only that, you know what happens if you do this, or if you do this, or if you do this. So today we're going to take a deep dive into what happens depending on what is underneath the radical in the quadratic formula. Okay, that number, b squared minus 4ac, is called the discriminant because it helps you figure out how many solutions you're going to have. I'm going to take this problem for example. A equals 1. B equals -2, C equals -8. The b squared minus 4ac for this is going to be -2 squared minus 4 times a times c. All right, so that works out to 4 plus 32, which is 36. If the discriminant works out to a positive number, we are going to have 2 real solutions. Now, 2 real solutions means 2 numbers that exist in the real world. And the reason there's going to be 2 of them is because the number that I get out of the discriminant, I'm going to do plus or minus that. So, if my discriminant, b squared minus 4ac, is a positive number, I'm going to have 2 real solutions. Now, sometimes b squared minus 4ac equals 0. Let's take a look at what that would be. A equals 1, b equals 4, c equals 4. Now, this is not happening just because b and c are the same, so keep that in mind as we go along. B squared minus 4 times a times c. Oh, 16 minus 16. That's 0. Well, if I take the square root of 0, I get 0, and adding 0 and subtracting 0 makes no difference. Those are the same thing. So each one of your solutions, even though you're going to do that twice, each one is going to be the same. So when the discriminant is 0, we're going to say that there is 1 distinct real solution. Now, the one that comes next is really going to help us see what's going on with this, okay? Okay, so here's our last situation. What happens if b squared minus 4ac is a negative number? All right, here a is 1, b is 1, and c is 3. Well, b squared minus 4ac is going to be 1 squared minus 4 times 1 times 3. Which is 1 minus 12, or -11. Now, we know from our earlier classes in arithmetic and mathematical modeling that we're not allowed to take the square root of a negative number yet. Okay, you will learn in Algebra 2 how to do that. But for now, we are going to say, since we're not allowed to take the square root of a negative number yet, we're going to say 0 real solutions. So, to summarize that, we now know what happens if the discriminant is positive, if it's 0, and if it's negative. And that's all the possibilities there are. All right, so here's a summary for you. If b squared minus 4ac is positive, your equation is going to have plus or minus the square root of some positive number. That's going to give you 2 real solutions. If b squared minus 4ac is 0, you're going to have plus or minus the square root of 0. Now that's not 2 different numbers, so you're going to have 1 real solution. And if b squared minus 4ac is negative, you would have something like this. Plus or minus the square root of a negative number. Since for right now we can't take the square root of a negative number, that's going to give us 0 real solutions. Now, how can we put this into some sort of application? What's the point of this? Well, if I ask you, hey, look at this graph on the left. Is its discriminant positive, 0, or negative? You can say, oh, well, I know something about the discriminant. I know that it tells me how many solutions the graph has. So if I see a graph that has 2 x-intercepts, I can say, oh, 2 solutions, that means the discriminant is positive. When I look at this graph on the right, I see, hey, it's only got the 1 solution. So if it has 1 solution, the discriminant must be negative. No, that's not true. It has to be 0. What am I saying? Ha! All right, folks. Thanks for watching. Hope you got something out of it. Here's one to go out on. X equals opposite b plus or minus the square root if b squared